Derived physical quantity, the physical quantities which depends on fundamental physical quantities are called derived physical quantity. And in this topic what we are going to learn, for derived physical quantity, how to write down the unit and how to write down the dimensional formula or df. So velocity, let me take, for velocity is a derived quantity. Velocity equal to displacement by time. Displacement by time. Displacement, for displacement it is meters, unit is, for time it is second. So meter per second is the unit. And what is the dimensional formula? Displacement means it is also length, that is L. For length dimensional formula is L. For time dimensional formula is T. So LT minus 1. There is no M term. That's why M0 L1 T minus 1, and we keep generally in square bracket. This is the convention. Suppose if you write down left side the physical quantity and right side the dimensional formula M0 L1 T minus 1, we call this as dimensional equation. We call this as a dimensional equation. And 0 is dimension of mass, 1 is dimension of length, minus 1 is dimension of time in the dimensional formula of velocity. Now speed also same. Speed means path length by time or distance by time. Distance means also we measure in meters, time in seconds, so meter per second is the unit, and the dimensional formula is for distance L, length it is also a length, by T, so it is LT minus 1. So every time I am not going to write M0 L1 T minus 1, just I will keep like this. Next, acceleration. What is the acceleration definition? Change in velocity by time. Change in velocity by time. One velocity minus another velocity. 4 meter per second minus 3 meter per second. What do you get? 1 meter per second. So again you will be getting the unit of velocity only. Difference of velocity has same unit of velocity. So difference of velocity also has the same dimensional formula of velocity. That means delta V dimensional formula and velocity dimensional formula are same. But velocity dimensional formula is LT minus 1 by time is T. What you are going to get? LT minus 2. So the unit is, for difference of velocity it is meter per second by second. What you are going to get? Meter per second square is the unit. Now linear momentum. Linear momentum, P bar is equal to M into V bar, mass into velocity. So its dimensional formula is, for mass capital M, for velocity LT minus 1, so LT minus 1, MLT minus 1 is the dimensional formula, and unit is, for mass it is kg, for velocity it is meter per second. For velocity it is meter per second. So kg meter per second is the unit of linear momentum, and force is equal to mass into acceleration. So mass is m, acceleration is LT minus 2. So LT minus 2. So MLT minus 2 is the dimensional formula of force. So the unit is kg meter per second square. but we don't use it. We use SI unit, that is Newton. N, capital N symbol we are going to use. So it is Newton. Next to area, surface area. Area is equal to length into breadth. For length L, breadth also you will measure in meters. So L square is the unit, meter into meter. You will be getting meter square is the unit for surface area. And volume is equal to length into breadth into height. Length is also length, breadth is again one more length, height is one more length. So L, what do you get? L cube. So meter cube is the unit. Now density equal to mass by volume. Mass is capital M, volume is L cube, so ml minus 3. So what is the unit? For mass it is kg, by for volume it is meter cube. So kg meter kilogram per meter cube is the unit for density. In this way we are going to calculate the dimensional formula of every physical quantity, but the only thing you have to know is the definition of that physical quantity. Velocity equal to displacement by time you have to know, then only we can derive the dimensional formula of velocity. Force is equal to mass into acceleration you have to know. Whenever you know this formula, then we can derive its dimensional formula and also unit. But SI unit you must have to learn for which physical quantity this unit is assigned. So some physical quantities are assigned the scientist's name as the unit, so that you have to learn. For force it is Newton, for power it is watt, for work done it is joule, for energy also it is joule after the scientists. So knowing the formula is very important. If you don't know the formula, you can't derive the dimensional formula of different physical quantities. It is very difficult, and also it is very difficult to by heart all these things.